One of the reasons that the chain rule is so powerful is that we can actually use it more than one time in a single problem. Sometimes I think about this as chaining the chain rule. Let's look at a couple of examples. So let's find the derivative of this function. We're given e all to the power 2x plus 1 cubed. And we want to use the chain rule. So let's do this very carefully. The way that I like to think about the chain rule is that I think about my function f as being e to something. We'll put a star there. Where the star is my inside function, 2x plus 1 cubed. So then f prime of x, using the chain rule, is the derivative of this thing, which is just e to the star, times the derivative of the star. Well, now I can go back and put the star in again. So I have e to the 2x plus 1 cubed, remember that's the derivative of this outside function, times the derivative of 2x plus 1 to the third power. Okay, well, now we could think of this 2x plus 1 to the third power as another use of the chain rule. So we can think of 2x plus 1 to the third power as some other kind of thing, maybe a big long blob this time, raised to the third power, with the blob being 2x plus 1. So what do I do then? Well, if I take the derivative of something to the third power, so the derivative of 2x plus 1 to the third power is, well, 3 times the blob to the second power times the derivative of the inside thing, the blob. All right, so this is a big mess, and we know what the blob is, so we can just plug that in to x plus 1. So what I really have is 3 times 2x plus 1 squared times the derivative of 2x plus 1. Well, the derivative of 2x plus 1 is just 2. So this is 3 times 2x plus 1 squared times 2. So then going back to f prime of x, this is now e to the 2x plus 1 to the third power times, well, we need the derivative of 2x plus 1 to the third power, and that's exactly what we just found here. So times 3 times 2x plus 1 squared times 2. Right? So if I did this all in one step without so much extra crazy notation, it would look like I take f of x to be e to the 2x plus 1 to the third power. And then f prime of x, well, the outermost function is e, so I take the derivative of e to whatever, I always get e to that same thing. So I have e to the 2x plus 1 cubed times the derivative of the inside function. And what's the derivative of that? Well, I take the derivative of 2x plus 1 to the third power. That's 3 times 2x plus 1 squared, right? Because this is something to the third power. So I'm sort of, the next most inner function is this cubing function. So derivative of the cubing function, leaving the inner function alone. And finally, the innermost function, I take the derivative and I get 2. So you can see we got the same thing in both cases, but here I did it just by thinking about the outermost function, e, the next most inner function, which is the cubing function, and then finally the most inner function, which is 2x plus 1. So I just keep on chaining the chain rule until I get the derivative. So the trick here is to just keep taking the derivative from the outermost function and then to the innermost function. Keep multiplying by the derivative. Let's see another example to make sure we've got the concept down. Here's our second example. This function is even more complicated. Let's take the derivative. So in this case, I want to evaluate the outermost function, and that is this sixth power on the outside. So to take the derivative of something to the sixth power, so the derivative is equal to 6 times the inside function, whatever it is, so square root of e to the 4x minus 1 plus x cubed, just copy that down just like it is, raised to the fifth power. But I'm not done because I have to take the derivative of this innermost function. this is going to be a little more complicated. So let's multiply by the derivative of the innermost function. Way over here, I'm going to worry about this derivative in a second. Here I have x cubed, so I know how that derivative is. It's 3 times x squared by the power rule. Okay, so now let's worry about this derivative of the square root of e to the 4x minus 1. Okay, well, again, I want to find the next innermost function, and that's going to be this square root. And I'm going to use the power rule again and think of the square root as e to the 4x minus 1 all raised to the 1/2 power. So I have 1/2 times e to the 4x minus 1 to the 1/2 minus 1, which is a negative 1/2 power. But I'm still not done, because I have something inside the square root, which is this function e to the 4x. So the next thing that I have to do is multiply by the derivative of the next innermost function, and that's e to the 4x. Well, it's not exactly e to the x, so I still have another layer of the chain rule after that. So I have here the next innermost function is e, and e to the anything is the derivative is just e to that same thing. So this is e to the 4x. But again, this is another function inside the e to the x, so I have to finally multiply by the derivative of this last function, which is 4. All right, so here were a whole bunch of functions. The outermost function, I have some big blob to the 6th power. So I have 6 times blob to the 5th power times the derivative of the blob. All right, so then we evaluate what is the derivative of the blob. Well, the x cubed, that derivative is fine. And by the fact that the derivative of the sum is the sum of the derivatives, I can just put that derivative there and not worry about it. So then I'm worried about this function, e to the 4x minus 1 to the 1/2 power. So again, I have some blob raised to the 1/2 power, which means I take 1/2 times the blob to the negative 1/2 power, right? Subtracted 1 from my exponent. But I still have a blob on the inside, so I have to keep going and figure out what is the derivative. Well, the inside function is e to the 4x minus 1, and so again I can use the sum rule. This 1 disappeared because the derivative of the constant is just 0. And then I take the derivative of e to the 4x. Well, this is e to some other blob, and so I have the derivative of e to the blob is e to the blob times the derivative of the blob, which in this case is 4x, so the derivative is 4. All right, so there's a couple of different explanations about where we got this derivative, and this here is the answer to what is the derivative of this function. You might have to go through it a couple more times. Try to do it on your own without the video leading you through it, and make sure that you remember all of the different parts of the derivative of this function. There's a bunch. We have about 3 or 4 different applications of the chain rule happening in this one single problem. But once you get pretty comfortable with the power rule, the derivative of e, and the chain rule, you can differentiate difficult functions like this with no problems at all. So keep practicing. Good luck. And if you have a question, let us know.